Hi there, this is Jacob Nash, Engineering Lessons, and this is Unit 1.3, Lesson 5, Thermodynamics, Problem Type Number 4, Energy Transfer using Stefan's Law. And if you remember, energy transfer is represented by Q. Now, so first, what is Stefan's Law? Well, it states that all objects lose and gain thermal energy by electromagnetic radiation. And the equation that can be used for this is Pnet, so net energy transfer, equals sigma times A times E times, in parentheses, temperature 2 to the 4th power minus temperature 1 to the 4th power. Now that looks crazy, and honestly it is. It's a little bit complicated to solve this kind of problem. We get extremely big numbers because you can see of the to the 4th power. And sigma is once again a Greek letter. Sorry if you don't like that, but that's just what is used in a lot of equations. I mean, there's lots of ones we've used so far. We've used delta, we've used omega, both lowercase and uppercase. We've used that symbol for torque. We've used that pi. You know, we use lots of Greek letters in engineering and lots of equations. So that's sigma, and always this equals in this problem 5.6696 times 10 to the 8th power. Sorry if that looks like 9, but that's 8. So that's always what that equals. That's what you plug in for that. Then A equals area, E equals, this is a lowercase e, emissivity, and T2 is temperature 2, T1 equals temperature 1. We'll explain how you can tell which one is which. So first, let's read this word problem. A student rides his bike home in the middle of winter, home to school. From home to school. I left out that word, sorry. The ambient temperature is 55 degrees Fahrenheit. The student's skin temperature is 96 degrees Fahrenheit. Determine the net energy transfer by using Q. That's what we're trying to find, Q. From the student's body during the 26-minute bike ride home due to electromagnetic radiation. Takes us back to Stefan's Law. Skin emissivity is 0.9. The surface area of the student is 1.92 meters squared. Yay. I already put it in meters. That's useful. Now, like with other problems, there are certain things that have to be in certain units. For this, time has to be in seconds. Has to be in seconds. In this case, it's minutes. It's easy to convert, though, to minutes. All you have to do is multiply by 60. We'll do that later on. Also, temperature has to be in Kelvin. That's what it has to be. It's in Fahrenheit, so we're going to have to convert. We'll do that later also. So, what equation can we use? Well, if you go back to the lesson 1, what we use to find Q is M times C times delta T. That's useless, though, because none of those things apply to this problem. Instead, we have to use a different equation that I gave you, which was the equation that was P equals Q divided by T. Wait, yeah. Or what was that one that I gave? I don't think so. Never mind. Forget that. We're going to use the equation Q equals P power times time in seconds. Remember? It has to be in seconds. So, first, we might as well just do the easy part first. Find seconds. So, we see that it's 26 minutes. So, let's multiply that by 60. 26 times 60 equals 1560. So that's what we plug in for that already. All we need to find now is P. Now, I don't want to make that sound like it's simple, because this is a very complicated thing that we're about to do, and it may make you kind of go crazy for a second. But we first need to figure out what we need to use this equation to find P. We need to figure out what we know. What variables do we know? So we obviously we'll just check off if we know it. Make this a little bit smaller. We know sigma. We always do, because that's given. It's always that number. Do we know A, area? Yes, 1.92 meters squared. So we'll do that. So we do know that. That's good. Basically, we're going to check off everything, because you have to know everything in order to solve anyways. Emissivity. We found out that was 1.9 for skin. No units for emissivity. Then temperature 1, temperature 2. Temperature 1 is going to be the 55 degrees Fahrenheit. And temperature 2 is going to be the 96 degrees Fahrenheit. But we have to convert those to Kelvin. How can we do that? Well, on the formula sheet, it says how to convert from Fahrenheit to Celsius, but not how to convert from Fahrenheit to Kelvin. But all you have to do is pretty much combine those two equations, and really the actual equation to find Kelvin is going to be Fahrenheit, the temperature in Fahrenheit, minus 32 divided by 1.8 plus 273. So we just have to use these temperatures and do that. So we know how to solve that. All you have to do is plug in this for F and then this for F. I'm not going to write it out just for sake of time once again, but you know that's what you do. You just plug that in for F. So for the first one, we're going to do the 96 first, because that's temperature 2. We'll do 96 minus 32, that's 64, divided by 1.8, that is 35.5 35.56 plus 273 is 308.56. So in Kelvin, temperature 2 is 308.56 K. Now we'll do the 55. So 55 minus 32 is 23, divided by 1.8 is 12.78. 12.78, and I rounded, by the way, plus 273 is 285.78. Now, you know you've done it right if still, this one in Fahrenheit, the temperature 2 was higher, so it still should be in Kelvin. If I accidentally got something lower than 285, then you would know you did it wrong. So now we have all of the things, and we can pretty much plug in the numbers here. Now, it's not hard to figure out where, like the conversions. What's difficult is to know how to solve this correctly. You cannot type this in the calculator all at once. You cannot do that times that times that times that to the fourth minus that to the fourth. You can't do that. You have to do it separately. But first, we can plug in all the numbers. So first, sigma is 5.6696 times 10 to the negative 8. Then we have A, which is 1.92. Don't need to put the unit right now. Then we have 0.9. That's the emissivity. Then we're going to do a bracket instead because this is emphasized, this part. Then we have 308, 0.56. Yeah, 56. Don't need to do the unit right now. To the fourth minus 2.85, or sorry, 285.78 to the fourth. Then, now what? Well, first, let's just do this first part. Forget about that exponent part. Let's do this. Multiply. That's not it. Multiply these three things. Now, something to note is that leave out that 10 to the 8th power for now, okay? Just do 5, what I underlined in red. Just do first 5.6696 times 1.92 times 0.9. We're going to leave that separate from it for now. We'll add it in later, but we'll still have an answer that's something times 10 to the negative 8th. So let's see. 5.6696 times 0.192, or sorry, 1.92 times 0.9, and we get, oh, I want black, 9.7, oh wait, no, that would actually just round to 9.8 times 10 to the negative 8th. We didn't add that in because if you did do that, you would get, let's see, oh, you would get 9.8 e negative 8th, and that, oh, that's just too crazy to look at. So it pretty much is that anyways if you type that in. That it's just basically a incomplete answer. We will eventually add that in. So now we have to do this part, and this may seem completely crazy to you, but you need to make sure that once you type this into the calculator, you do it right and you write it down right away what it is. So it's going to be this times some crazy numbers we're about to get. So first, let's do 308.56 to the 4th power. In the calculator, you can push the caret button, which looks like this, to add in the 4 to the 4th power. And you get a huge number. So I'm just going to write it, and then I'll say it after I write it. Oops. I'm going to make sure I do this right. 7. So it is 9,064,805,779. And the number will not stay that big for long, don't worry. Then we have to do 285.78 to the 4th power. Once again, big number. We get 6,670,022,940. Okay, since that's in brackets, let's do that part first. So 9 billion, make sure you type this right, 9,064,805,779 minus 6,670,022,940 equals 2,308,000,000 394 million 782,839. Wait, what? Sorry. 839. And that is going to be multiplied by 9.8 times 10 to the 8th power. So first, we will do 9.8 times 10 to the negative 8th. That's in parentheses. Then multiply that by 2,394,782,839, and you get, luckily, a smaller number. We get 234.69 approximately. And then what's the unit for power? It is watts, so W. That, we did all of that only to get the P. That's not even our answer to this question. Now we have to plug this down here into the equation because it's P times T. We already did T earlier. We just did P, so 234.69. We don't have to do units, and then that equals, so let's see, 234.69 times 1,560 equals 366,116.4 joules, because that's what energy transfer is measured in. That is the answer to this question, and that took a long time, but once you get used to it, you will it will go quicker. And it was just because I was saying it out loud. Now, the biggest thing with this, it's not really that hard to figure out what the answers are to plug in. The tricky part is just really just putting it into the calculator and remembering those billion numbers. And our end result ended up being a big number, but at least it was only in the thousands. It wasn't even in millions. So that would be it for this video. I hope you enjoyed it, and I hope it helped you. Feel free to ask a question in the chat, or I meant in the comments, if you have one, and I'll try to get back to you about it. If I don't, then hopefully someone else will be able to help you, and there are plenty of videos out there to help you further, and I'm sure your teacher would be glad to help if they're a decent person. So, thank you for watching, and I'll see you on the next video.